723 degrees Celsius, yan yung crystallization temperature natin. As you could see here, ito po yung mga heat treatment area po natin. So if you have a picture there, no? Kung very photographic memory po kayo, so I'll just go sa next slide. As you could see, the effect of heat treatment in steel as well as let us say cast iron, no? Also, anilin po ang heat treatment natin. Kung gagawin po ninyo doon is pwede nyo ma-form ng maayos yung bakal. Okay, so kung meron kayong pagawaan dyan ng metal, nakita ninyo yung bakal is heat treated, so i-anil po muna natin bago natin siya ipakain sa talim. Say for example, yun po yung mga example doon. Machinability as well. So kung coarse grain annealing po tayo, sa soft annealing, kita po natin kanina, that is above the recrystallization temperature. Yung homogenization, alloying element, so nandun pa rin po sa above recrystallization temperature. Kita po ninyo kanina. So you wanted na diffusion annealing or solution annealing ang gagamitin po ninyo. When you wanted the recrystallization annealing or coarse grain annealing as well as normalizing, you wanted to adjust the grain size. So perfect po ito doon sa mga merong rolling mills. So pag na-flattened na yung mga crystal mo, so you wanted magkaroon ng adjustment on grain size, and also kapag gusto mong magkaroon ng stress relief annealing. Okay? So mga rolling mills. And then if you wanted na mas mataas ang strength, so you wanted your metal to be quenched and then temper or soft annealing, and then of course normalizing. So yung forging, once na na-forge natin, di ba mainit po yung bakal, usually hinihit treat po yun, ang ginagamit po is normalizing. So mas matigas po ng konti yung bakal than doon sa soft annealing. Okay? Increasing hardness, of course, you wanted hardening, so gusto niyo ng quenching, ayan po yung mga heat treatment. Ayan, so time check, it's 11:25 and I have 34 more slides. So dapat 1 minute per slides. As you could see here sa rolling mill, as you could see po, once na cold, di ba cold po ito, no? Cold working, so below recrystallization, as you could see, yung coarse grain po niya, then pinas natin sa rolling mill, you have a rolled steel deformed grains. So there are stresses in here. So if you wanted release those stresses, you wanted it to be heat treated. So ang gagawin lang po natin is recrystallization or annealing temperature, just above your recrystallization temperature. But if you want kailangan nyo lang po ng residual stresses, matanggal na stress relieving, so just below lang po ng recrystallization. So you could see kanina dun sa, sabi ko sa inyo yung photographic, if you have a photographic memories. Actually, makikita naman po yan sa internet. Okay, I hate saying that, but makikita naman po siya. Okay, so as you could see here, yung microstructural changes, high temperature. At elevated temperature, you have ferrite and pearlite. Then you have ferrite and carbides, no? And then yung pearlite and cementite, kapag itinaas po natin, ferrite plus carbides. Ito po yung nakita ninyo doon sa right side ng ating iron carbide diagram. Okay. So ngayon, kapag nagkaroon po tayo ng quenching, sinasabi, ikaw ba naman na sobrang init ka tapos idump ka sa malamig na tubig, anong mangyayari sa'yo? You chill, parang gano'n, you chill. And then, ano mangyayari? Dahil na-chill yung mga content mo na carbon, nag-iiba yung structure mo doon sa bakal. Ang nangyayari, sisingit ngayon, sa halip na pumunta dahan-dahan yung carbon mo, doon sa interstices ng inyong BCC na iron, ang ginawa niya, na-trap na siya doon sa location na yon. Okay? Na-freeze siya doon. What happened is that, nagalaw mo ngayon yung matrix ng BCC. So that is why, nagkakaroon ka ng tinatawag na martensite formation. So the more content mo ng carbon, the possible to have a martensite. So kapag lesser than 0.18, 0.20 carbon ang iyong carbon, hindi ka makakaroon ng possibility na na mas matigas ang bakal mo to form martensite. Again, martensite is very, very hard. Ikaw ba naman, bigla kang nilagyan, ininjekan ka ng carbon na hindi doon sa dati niyang pwesto. So magkakaroon siya ng maraming stresses sa loob. So that is why when you heat treat at quench mo ang bakal, it is possible na bigla nyo lang siyang mahulog yung bakal, it will break. It will definitely break because of that high, yung energy doon sa loob. Medyo yung reaction doon sa loob, the energy inside ng bakal ay masyadong malakas. That is why pwede po siyang magkaroon ng breakage. So what is the effect? So ipakita natin doon sa microstructure, no? Sabi ko nga sa inyo, pupunta tayo inside the metal. So as you could see, in slope cooling, normally, naandun siya sa loob lang ng interstices. Ano po? Sa loob ng interstices. Whereas pag rapid cooling, it is forcibly dissolved inside doon sa isang matrix. Nag-iba ngayon, tumaas na yon. Kita nyo na andun lang siya sa interstices. Pero siya sumakop na ng isang tawag nito, doon sa interstices mo, bigla niyang ginalaw. Kaya kung bakit, lumaki yung size ng iyong BCC iron. So yan po yung nangyari doon sa martensite formation. Okay? So kapag nagkaroon po kayo ng martensite formation, the one thing that you need is, kanina sinabi 0.20%. Pero dapat, kung talagang gusto nyo all over the metal, kailangan po ng greater than 3%. Okay? Or 0.3%. Pero kung 0.2, 0.18% lang ng carbon, naku, patsi-patsi po, magkakahiwalay yung martensite formation mo. So, ibig sabihin, hindi matigas yung buong bakal mo. So, if you wanted your whole metal na magkaroon ng martensite formation, it is more than 3%. Ayan. Okay? So, yung insolubility of carbon in the ferrite lattice, kasi nga, sabi nga natin, kaya lang i-dissolve yata ng ferrite sa lattice niya is, na carbon is around 0.07, something like that. So, hindi ka makaka-form ng martensite. Okay? As you could see it here, ayan po yung C45 steel. Kapag hardened po siya, napakataas po ng strength niya. Kapag normal lang siya, kaya lang po yung magiging strength niya. Kaya pag normalize mo lang po ang heat treatment, dito lang po ang strength niya. So, you choose where to apply your metal. What is the application of your metal? So are you going to heat treat it? Are you going to just same as that as wrought iron? As produced lang ba siya? Or are you going to normalize? Depende po sa inyo kung ano yung magiging application ng inyo bakal when it comes to when you wanted it to be heat treated. Ayan. Another one is through the addition of carbon. So sa MIRDC po, we have carburizing. Have you heard about carburizing? Wherein, yun nga po, doon lang tayo nagkakaroon ng martensite doon sa kanyang surface, yung martensite. So doon lang nagkakaroon ng martensite. Whereas doon sa loob po ng metal niyo is a very coarse grain na po siya. Okay? So carburization heat treatment po ang gamitin din or flame hardening. So as you could see it here, ayan, medyo matigas siya for wear resistant dito sa dun sa gears natin, and then very mulat po siya doon sa loob. So you can do that kung ikaw ay isang design engineer, ano yung gagawin kong processes so that I could alter the strength of my metals surface and beyond the surface of your metals. Okay. So yan. Ayan. So ito na po yung pinaka-last nating topic, which is overview of the heat treatment. So kanina, tiningnan natin lahat yung inside the metals. So sabi natin, kapag hini-heat treat po natin ang metals, they are of course, what you call this, dahil sa energy, nagkakaroon ng I forgot the term in metallurgy, nagkakaroon ng driving force, nagkakaroon ng driving force so that yung solute mo and the alloying element interact with your matrix. Yan po yung nangyayari. So yun yung nakita natin doon sa pinakita kong metallography. Yun po yung metallography kanina. So nakita ninyo ang adaptive metallurgy, kasama niya yung metallography, nakita natin ano yung nangyayari sa loob ng bakal. Ayan po. So as you could see. Okay? So overview of heat treatment, ang discussion outline po natin is what are the heat treatment processes. So again, yung phase diagram, i-relate natin sa phase diagram. And then of course, what are the benefits of heat treatment? And then lastly, of course, is what are the MIRDC heat treatment technologies or furnaces inside the Metals Industry Research and Development Center. As you could see here, na-discuss natin kanina, heat treatment is the controlled heating and cooling of metals in order to deliberately alter their physical and mechanical properties. Some has changes on chemical properties, especially when we are heat treating aluminum alloys. Sometimes yung aluminum alloys, overage namin. So, paano yung overage? Niluluto namin yung aluminum for about 7 days inside the pugon. So, at around, sabihin natin is around 100 degrees Celsius, na andun lang po siya sa loob ng pugon at 100 degrees Celsius. As you could see, pag tiningnan po namin yun when we look at under the microscope, pag nakita po niya, para siyang puro tagihawat, no? Makinis na maraming grain boundaries, tapos puro tuldok-tuldok. So nag-precipitate na ngayon yung iyong mga carbides as well as your alloying elements. So that is why it is a very, very, pag overage, sometimes hindi na siya kayang atakehin ng chemicals. That is why yung ibang aluminum na alloys, nilalagay siya doon sa malapit sa mga malalaking turbine engines. So doon siya nilalagay para hindi siya agad-agad magkaroon ng atake ng ng chemicals. Napag-aralan natin kanina, di ba? Yung grain boundaries are very susceptible for intergranular attack as well as for chemical attack as well as yung forces ng mechanical, no? So yun ang ginagawa po namin para mawala yung intergranular cracking, ino-overage namin sa heat treatment yung aluminum. That is why they are applicable doon sa maiinit na lugar. So pag mainit po yung lugar, di ba, doon nagkakaroon ng forward reaction ng chemical reaction, sorry. So that is why may mga aluminum na pababa ang kanyang strength but yung corrosion properties niya ay mataas. Okay? Just wait a minute lang po. Ayun, may concern si Sir Charlton. Okay? Actually, sir, what I did is ang ginawa ko po is binilisan ko po yung discussion so that I could have until around 12 kasi after 12 ko meron pa kayong gagawing ano bang gagawin nila Ma'am Jo? Meron pang assessment pa. So I don't like to ruin your lunch and your time. Yung break time niyo, lalo na yung mga nagtatrabaho from 12 to 1. That is why medyo binilisan ko po yung discussion. So, I'm sorry for that. Ngayon ko lang po nakita. Okay? Ayun. So, sorry Sir Charlton on that. Okay, so, as we can see here, yung controlled heating. So, yung heating, dapat controlled siya. Sometimes, specified pa yan ng inyong customers. So, say for example, ako sa isang heat treatment facility in aerospace, no, ang gusto lang ng taas ng temperature is dapat 5 degrees Celsius per minute or per 2 minutes or per 5 minutes, something like that, to go para mapuntahan niya yung pinaka-solution heat treatment temperature. And then holding temperature. So holding temperature is controlled. Dapat, say for example, yung kanina nakita natin at 800 degrees Celsius, yung austenitizing temperature. Say we put the bakal in that austenitization temperature, which is about 800 degrees Celsius, 700 degrees Celsius, 900 degrees Celsius. Dapat doon po sa specified temperature, take note po, bawat bakal, bawat alloy, bawat grade ng bakal, bawat kapal ng bakal has a different temperature and time. Ano po? So yung holding temperature niya will depend on the thickness. Okay? The time pala, sorry. The holding time is dependent on the thickness, the cross-section, the most thickest or the thickest cross-section of your specimen. Sorry, may tinignan lang po ako dun sa likod. So it will depend on the thickest section. So say for example, ang rule of thumb po natin dyan is 1 hour per 1 inch cross section, yung thickest section po ninyo. So sabi natin, kapag hinold mo yun ng ganon temperature, so definitely lahat ng alloying element mo magdi-diffuse na doon sa matrix ng iyong bakal. So parang gagalaw na po sila doon. In layman terms, magdi-diffuse po sila. Mag-a-arrange po sila doon na homogeneous po sila. Okay? So ganun po yung nangyayari inside your bakal kanina. So you hold it at that temperature. Dapat hindi bababa, hindi tataas. Doon sa in industrial practice, no, sa ginamit po namin, hindi po kami bumababa ng plus minus 10 degrees Celsius. Ayan. So dapat yung pugon mo, hindi dapat bababa yung temperature mo during the holding temperature, say for example 850 degrees Celsius. Dapat hindi siya bababa ng 839 at hindi siya tataas ng 861 degrees Celsius. Dapat kung kaya ninyo yung makontrol ninyo as a process engineer, makontrol ninyo yung pugon ninyo ng around 5 plus minus 5, say for example 850, so 855, maglalaro lang siya ng 855 to 845 degrees Celsius. Doon lang naglalaro yung temperature nyo when you hold your pieces inside your pugon. So paano nyo magagawa yon? Of course, dapat magaling yung maintenance ninyo. Say for example, dapat okay ba, equipped ba, calibrated ba yung inyong temperature gauges, yung controller po ninyo, as well as your thermocouple po ninyo is okay. So yun po yung gagawin po ninyo. Dapat maganda lagi yung inyong pugon. Secondly, maganda ba yung insulation ng inyong pugon? And then thirdly, yung mga elements ng inyong pugon ba is okay. So again, when we are in the very mataas po kasi yung when it comes to aerospace heat treatment and processes and other processes, when your product is going to aerospace industry, grabe po ang strict ng po dyan, ng quality. So kami po, pumapasok kami ng pugon kasi napakalaki ng pugon, no? We adjust the coils, we adjust the vents inside kasi yun yung model ng namin model ng tawag namin heat treatment nagbo-blow ng mainit na hangin not direct, no, hindi siya direct kasi baka magkaroon ng radiation effect, masira yung bakal mo. So yung mga ganun po. So what we do is we inaayos namin yung fan and then we have a regular temperature regular temperature survey. So ibig sabihin lang po, okay, thank you sir for acknowledging. So ang ginagawa po namin doon, inaayos po namin yung sobrang laki. So dapat hindi lumalampas ng plus minus 10 yung namin temperature. Then yung cooling po, ayan, kinokontrol din po yan. If you wanted to have a martensite kanina, dapat as much as you can, dapat ma-quench mo na siya. So yung quenching agent po natin are oil, can be water, or can be some types of plastic or glycols. So itutubog niyo po siya doon. Okay? So dapat ang time and temperature po ninyo ay controlled lahat. Yan po ang heat treatment process. You have 3 main processes here that are being controlled. I don't know what is happening to sa likod ko. Anyway, so this is a typical chart of a heat treatment process. Say for example, no, hindi na maayos yung iyong furnace, no? So tapos i-heat mo siya sa 850 degrees Celsius. So say for example, from time 0, dapat pumunta na ng 600 degrees Celsius. So sabi ko nga sa inyo, itong incremental change na to, nasa inyo po yan or depende sa customer ninyo kung ano dapat ang rate niyan. Say for example, 1 degree per ganito, per minute, hanggang makaabot siya ng 1 hour. Then, nung 1 hour, ikinukul mo muna, tawag nito, para hindi masira yung bakal mo, lalo na yung maninipis, no? Yung maninipis kong bakal. Usually, nagkakaroon po ng maraming hagdan para sabay-sabay po silang, tawag nito, sabay-sabay silang ma-hit. Ganon din yung makakapal, no? Nilalagay natin sa intermediate zone para lahat ng bakal, sabay-sabay silang pumasok doon sa tinatawag natin post-sanitizing temperature. Okay? Ito lang po ay intermediate na po. So, kung gusto niyo pong trend, dahil kayo, then mas nakikip mo yung cost ng heat treatmenting. Ito yung nangyayari once na luma ng furnace natin or hindi natin na-maintain yung furnace natin or yun nga, lumang-luma talaga yung furnace natin or merong mga something like may problem dun sa controllers natin, may problem sa insulations natin, and the like. Okay? Umuulan po pala. So baka marinig po ninyo ayan. So mag-hold po tayo. So depending po kung gaano kapalimbaan mo. And then again, you control cooling temperature. Ayan. So ito po ay quenching. When you quench, sabi po natin kanina is that yung loob ng bakal mo medyo nagkakaroon ng internal stresses. So that is why yung ibang ginagawa po nila nagkakaroon or normally talaga is standard is tinetemper po natin yung bakal. So pag nakita po ninyo dito yung transformation ng ating bakal when it comes to microstructure, first, let us say you have hypoeutectoid steel. Ayan, lesser carbon po siya. Ayan. I-treat po natin, magiging austenite po siya, and then you cool it abruptly or na mabilis, so you form a martensite. Ayan po. So after po ng martensite, usually po kasi is kailangan po natin siyang i-temper. Ayan. Okay? So when you use the austenite kanina, just to recall lang po, austenite ferrite, ferrite pearlite, cementite and pearlite. Ito yung kanina, yung austenite and cementite, pagdating po dito sa hypo at saka dun sa hypoeutectoid, ito po yung nagiging structure nila, higher temperature. Ayan. So yan po yung steel. Ginawan po natin yan ng istorya kanina. Ayan. So at around 8 degrees na to, meron tayong magnetic point. Diyan po nagkakaroon ng yung ibang property po. Actually, yung ibang property po yung ibang property po, dyan yung pinag-aaralan namin, lalo na ngayon, ewan ko kung isasama nila ako dyan, they wanted na yung ginagamit ng mga doktor natin for their operations, no, gusto nila controlled yung magnet. Kasi nga, di ba nga po, ang loob ng hospital, meron ng radiation, merong magnetic resonance, something like that, blah, blah, blah. Baka maapektuhan or something during the operations and the like. So, ito po kung mag-aaral pa tayo ng heat treatment, as you could see kanina, ito yung recrystallization temperature natin. Ito po ay tinatawag natin A1. Ayan, hindi po yung Singer. Yan po yung lower critical or LCT. Okay? So, beyond that, magkakaroon na austenation, no? Austenite formation. Okay? Whereas pag hypo ka, meron kang austenite at saka ferrite. So, kaya nga po, if ever na ang alloy mo is hypo, ayan, maunting carbon, ang heat treatment mo ay pupunta sa A2 or sa A3. Okay? Natandaan po si A2 or si A3. Ayan. Si A3 or si A2. Diyan po na ng hypoeutectoid steel na hini-heat treat. So, ibig sabihin po at around 800 degrees Celsius. Whereas, pag mas marami ang iyong carbon fiber, hindi na naman yung titigin. Okay. So, sa ACM, ayan, sa upper critical temperature, which is, ito yung ACM, okay, sorry. Ayan yung magiging gagamitin po ninyo. Hyper gagamit ng ACM, hypo gagamit ng A3, or yung dalawa pwedeng gumamit for recrystallization ng A1. Okay? Yung below dito sa A1 are those recrystallization as well as yung cold processing natin, whereas yung processing natin is the A1. Ayan po yung heat treatment. Remember this one po kanina? Lahat po ng soft annealing, yan, recrystallization ng healing, stress annealing, nandito po below. Whereas yung normalizing, diffusion annealing, or strain annealing, kailangan po siya itaas with one microstructure that is only austenite. Ano po? Austenite lang po dapat. Ito po ang gagamitin natin. Okay? So whereas pag normalizing ng nito ng hypo, pwede po dito. Alright? So pwede po siyang gamitin yung temperature na yon, which is around 700 degrees Celsius or above that. Around 750. Alright? So what are the benefits of heat treatment? So number one is to soften the metal. So kung nag-annealing ka, lahat ng processing ng annealing, softening process po siya. Pag nag-quench ka naman, it increases hardness. So kanina, nakita po ninyo doon yung nagkakaroon ng changes doon sa 700 degrees Celsius, 723 degrees Celsius. Dito po yung area ng electrical, heat conductivity, and magnetic property. Ito yung opportunity ng mga metallurgists in their industries na pinag-aaralan yung metal so that makapagbuo ng iba-iba pang metals na alloy ng iron. Okay? Say for example, gusto nilang maging magnetic yung metal at that stage and beyond. Okay? So nakita po ninyo, di ba, meron tayong mga stainless steel kagaya ng austenitic grade na hindi siya magnetic. Alright? So yan po yung nagiging result on. Again, pinakita po dyan, relieve stress. Again, if we want to temper, di ba, ite-temper natin yung martensite natin at around 300 degrees Celsius, between 300 to around 600 degrees Celsius, di ba, kinuench po natin siya. Ilalagay po ulit natin siya sa pugon, isasalang natin at 300, 400, or 500. Depende po sa tigas na gusto natin. Say for example, i-quench po natin yung bakal kanina, ano? Matigas na matigas po yun. Say for example na andun siya sa 65 HRC. Yun po yung hardness ng bakal, 65 HRC. Para mapunta siya doon sa 60, mapunta siya doon sa 55, i-temper po natin siya. Okay? So the higher the tempering temperature, say for example 500, mas lalambot po yung bakal natin. Okay? So mas marirelieve po yung stresses niya. Okay? Meron tayong tinatawag na super alloys which can be heat treated 6 times, no? Again, iba-iba pong process yung gagamitin. Okay? So, as a rule of thumb, kapag nag-heat treat po tayo ng bakal, huwag po nating palampasin ng 3 beses. Say for example, we have this ball pen. Say for example, metal siya. Na mali yung heat treatment ko. Say for example, ang nature niya is mas mababa doon sa target na temperature. Okay, say for example, 723 degrees Celsius. Hinitreat ko lang siya ng 600. Walang mangyayari talaga sa kanya. Tapos i-quench ko. Wala talagang mangyayari sa kanya. It's okay, okay ka pa nun. Pero kung inhitreat mo siya ng 900, pero andun lang siya sa 800 degrees Celsius, there is a detrimental effect on your metal on that. So those are things na kailangan ninyong malaman during the heat treatment. Okay? So kung medyo lumampas lang siya ng 10 degrees, then it will be okay, probably okay. Pero kung i-heat treat nyo na naman ulit, then magtaka na po kayo kung ano yung mangyayari doon sa metals ninyo. But it can be reverse reaction, no? So sometimes, yun yung iniiwasan ng quality when it comes to aerospace, no? Ayaw nga nila actually nang nire-reheat ang isang bakal kasi high nga po yung standard when it comes to heat treatment. Ito corrosion property I discussed when example niyan is doon sa aluminum. So there are 2 types of heat treatment. It could be softening or the hardening. Okay? So let us discuss each. Ayan. So sa softening, you have annealing. Actually, normalizing can also be hardening. Okay? but it is in the softening. And then we have sperodicing, stress relieving, and tempering. So yung annealing, kanina kita ninyo, it is above the recrystallization temperature, mostly. Ayan, yung normalizing na andoon sa above the AC1, AC1, AC3, and then ACM. Pag hypo ka, dapat above ng ng A1, okay? Normalizing, sterilizing, and then stress relieving, nasa baba siya ng A1, and then tempering na ando sa 300 to 600 degrees Celsius, or depende po sa inyong gagamitan, okay? So we have hardening, we have direct or true hardening, we have conventional. We use conventional or vacuum furnace in MIRDC. We also use surface hardening, we use vaporizing and nitriding, flame hardening, and induction hardening. Yun po yung mga example of hardening processes. Pag hardening po, usually you have a quenching bath. So kailangan nyo po ng mga oil doon. Mineral oil po yung ginagamit namin. Okay? So this is the example of direct or true hardening using conventional process. So meron po tayo dito sa MIRDC, meron tayong mga ganitong pugon. As you could see, it is lined by bricks. Ayan, meron pong insulation. And then of course, meron kang mga elements doon na heater. Ayan, meron po siyang mga heater dyan. Okay? So we use also yung cooling, the metals, para maganda yung pag-hit sa kanya. But pagdating po sa, mamaya, i-discuss natin. So just like this one, atmospheric po yung ginagamit natin. So ibig sabihin, 1 atmosphere siya. So papasok lang po natin sa electric furnace yon, yung ating bakal na nakapack ng carbon or ng uling. Ayan, para hindi mawalan ng carbon. Sometimes nagdi-diffuse po yung carbon on air. Sometimes ganun po. Kaya ang technique namin is nakapack po siya. So there is also a vacuum furnace wherein you don't have to pack your part. So ang nangyayari po diyan is kung ano yung bakal mo, pasok mo diyan, mahi-heat treat na po siya. Iwan mo yan, naka-program, matatapos siya, tapos agad siya, malamig na po yung bakal. So compared to conventional heat treatment, susungkitin mo pa yung bakal with the aid of your strength ng pagsungkit papunta doon sa oil, or with the aid of your crane, tatransfer mo doon sa quenching bath. Dito, ang quenching nito po is malaking blower as well as nitrogen na malamig. Okay? So yan po yung vacuum furnace sa MIRDC. So we also have this carburizing. Ayan. So we also have another vacuum furnace there which is being utilized. Now after ma-harden dito, we utilize this as tempering. So mga around 300 degrees Celsius up to 400 degrees Celsius lang ang gamit namin dyan. So pinaghiwalay po namin kasi ito yata is luma na yung furnace. So yun lang yung kaya niya. Hindi na kayang tumaas na at around 1,000 degrees Celsius. Mind you that yung austenitizing temperature natin is around usually 850 to 900 degrees Celsius. Ayan po yung mga vacuum furnaces. So what is the difference? Medyo malabo po, no? Teka lang. Sige lang. Sorry. Kung nababasa po, no? Ito po yung difference ng using atmospheric furnace and vacuum furnace. Kung makikita po ninyo, dito nagkakaroon ng scaling kapag atmospheric furnace. Whereas for vacuum furnace, kung ano yung furnace ay yung bakal na inilagay mo, kung gano'n siya kakinis, paglabas niya, gano'n din po siya kakinis. So, yun po yung difference niya. Another advantage is, ayan po, ayan. Process repeatability, temperature uniformity. Sa vacuum furnace po yan, reliable operations, better operating environment, no low environmental problems, and then of course, better application for computer control or computer controlled po siya. Yan po yung sa vacuum furnace. So, sabi ko nga, computer controlled siya, pindutin mo lang, press mo lang yung program once na naka-load na, then after 1.5 hours, tapos na po, matigas na po yung bakal. Ganun po yung nangyayari sa vacuum furnace. Whereas ang drawbacks po niya or disadvantages niya is higher capital cost. Ayan. Compared dun sa kanina, oil lang siya, mas mura yung oil. Dito, nitrogen yung kailangan mo at matalakas na power na electric fan. That is why mas malaki yung energy na gagamitin mo, mas malaki po yung utility cost or electricity cost. Higher operating cost, so you add capital cost as well as utility cost, mas mataas pa siya. The problem is kung hindi malaki yung vacuum furnace mo, of course, lower ang overall capacity. So, kasi medyo ang ginagamit natin dyan, medyo kokonti lang talaga po. So, less flexible po kasi nasabi lang po ito, depende doon sa kind of vacuum heat treatment furnace mo. Kung carburizing lang siya, carburizing lang po siyang may ibigay sa inyo. Okay? Ito po yung loob ng vacuum heat treatment furnace para makita po ninyo sa MIRDC. As you can see, ito po ay graphite. Tapos meron kaming special metal po, insulate, and another insulated, and then a jacketed yung vessel po. Ayan. And then of course, di nakikita yung naan dito. No? So, 5 liters lang po yan. And then, ito yung malaking vacuum pumps. Ayan, may vacuum pumps po siya. Dalawa po siya, series of pumps. Mechanical, isa, I think, isa. So, para makapunta doon sa vacuum state. Okay? So, I don't know if we can play this. Let us see. Ayan, yan po yung sa vacuum furnace po ng MIRDC. The thing here is you are going to put the metals na hindi pinakamahal sa kanila, ganun po siya talaga siya. Whereas, puro screw siya na maliliit, mag-overlap each other. So, pwede mag-overlap ang inyong metals dito sa furnace na ito. Whereas, doon sa conventional, pwede po siyang mag-overlap kasi nakapack naman po siya. Okay? So, ayan po. The other one is yung, nawala na. Same lang po siya, sorry. And then ito po yung huli natin. So, kaya kung ano yung tsura ng bakal, yun lang din po yung yung bakal na yung tsura niya. Unlike dun sa conventional, maluluto doon sa iyong oil. Okay? So this is the vacuum heat treatment. Once again, yung carburizing po namin, ipapasok po yan doon sa loob. Tapos dito sa loob, dito sa banda sa gitna, sa harapan, meron po diyang oil quenching tank po dito. So pagka heat treat doon sa loob, ibabagsak po niya yan dito. So already mechanized na po lahat. So again, sabi ko nga sa inyo, so, sabi ko nga po sa inyo, yung iba, meron pong mga ganitong heat treatment. So, if you wanted yung high level na heat treatment, also, sabi ko nga sa inyo, higher cost din po siya. So, tingnan lang po natin kung saan nyo siya gagamitin. So, I think that is all for me. Na ano ko yung 12:01. So, thank you very much for listening and sorry for the technical glitch a while ago. And I think we have some questions, or do we have some questions so far? Ayan.
Walang nakasulat, sir, sa chat. So,
oo nga po, baka na sila.
Oo nga. Are there any questions?
Malinaw naman po.
Oo.
Ayan. Meron po kayong question so far? Medyo itututok ko lang po yung speaker ko kasi medyo mahina. Sige lang po. Any question po on heat treatment and the overview on heat treatment? Kasi yung heat treatment is sa MIRDC is buo po yun, no, Ma'am Jo? Grabe yung tagal ng ano na yun eh. No?
1 week po siya.
1 week, okay. So this is just an overview. Pinakita ko lang po kanina ano yung nangyayari sa loob ng bakal at pag hinitreat natin, malalaman ninyo ano yung nangyayari dun sa bakal. So yun po yung metallography at saka heat treatment. So nakita po ninyo na if we wanted na matigas yung bakal, we heat treat it. If we wanted na malambot yung bakal, we heat treat it. So nasa sa inyo po kung saang process niyo siya gagamitin. Okay? Ayun. So may question po ba? Sana may question.
Pwede mo tanong, Sir Marvin.
Charlton.
Si Charlton po ito from UE. Ano po yung pinaka-advantage ng vacuum furnace compared to mga conventional heat treatment natin? At saan siya particularly ginagamit? Kasi 'di ba may mga kanya-kanyang application yun. Anong pinaka ng vacuum po? Vacuum. Saan ginagamit? Saka anong advantage?
Alright. So tama naman, no? Ang sa atin lang naman, no, yung vacuum is heat treatment siya. The same lang siya ng conventional. Okay? Same lang siya. Okay? Punta tayo dun sa same lang siya ng conventional. If we wanted naman na clean lang talaga yung bakal, no? Clean yung bakal, we use vacuum heat treatment. So most sophisticated industries just like yung ngayon, hindi naman tingnan mo dun sa experience ko, heat treatment namin hindi siya vacuum during the aerospace industry. Pero ang aerospace industry is very, very strict when it comes to processing. Hindi vacuum heat treatment ang ginagamit namin. But we have atmospheric or conventional heat treatment. So nasa sa iyo lang, it's your choice. Which vacuum which heat treatment facility are you going to use? Pero kung ang application mo na talaga right now, ang ano na ngayon, yung pataas na ngayon, yung uses niya talaga sa aerospace, yun na yung mga ginagamit nila, itong vacuum heat treatment. Ang isang explanation po dyan, kaya papunta tayo dun sa mga ganyan, is remember yung global climate change, yung mga European po is medyo strict sila when it comes to that. Kasi ang conventional po is medyo environmentally unfriendly. Okay? So, again, doon na sila sa mas malinis na technology. So, yun po yung nagiging nagiging choice nila right now. Again, if you wanted na sure na hindi, say for example, sophisticated yung mga materials mo, na walang migration or diffusion, say for example, ang gusto mo is, dahil vacuum state siya, no? Say for example, kanina ang binigay ko is aluminum. Gusto mong ang aluminum hindi siya mawala dun sa metal mo, na andun lamang siya, tapos i-heat treat mo siya ng 1,300 degrees Celsius. You use the vacuum kasi ang vacuum is, di ba ang vacuum state is zero, hindi nagkakaroon ng reaction. Okay? So you use that. So yun yung pwedeng gamitin na processes siya. So special processes for different alloys can be used dun sa vacuum. Sa tanong ni Sir Charlton kanina, right now sa amin, hindi namin most pa rin ng kliyente namin go with the conventional kasi ang application lang naman nila is, say for example, yung sa baril, patitigasin yung baril, yung mga ganun po, patitigasin yung kutsilyo, say for example, patitigasin yung gear, dun lang po sila right now. Pero kung kailangan po ng carburizing vacuum heat treatment, yun dun po, gagamit po kami noon. So depende po sa process. So iba-iba po siya. May vacuum, carburizing vacuum heat treatment, and plain carburized vacuum heat treatment. Depende sir, ayun po.
So wala pa po tayong kliyente sa MRDC na gumamit ng vacuum? Or parang
meron sir.
Meron na rin?
Meron sir. Ang ginagamit po nila, as I remember, is yung D2, yung mga pang-molde. So they use that.
Tool steel.
Kasi malalaking bloke siya eh. So pag dating doon sa conventional namin, hindi kakayanin. So yung mga ganun po. So sa D2, doon nila isinasalang. Depende po sa sa customer, kung gusto nila na hindi na nila kailangan linisin ang bakal kasi ma-oily po after no? After ng bakal. So hindi gusto nilang, ayaw na nilang isalang ng what you call this, yung paglilinis, yung mechanical shot blasting, something like that, or basta lilinisin yung bakal through mechanical means. Ayaw na nilang isalang doon. Ang gagamitin nila, agad, vacuum heat treatment. Depende po talaga sir kung ano yung susunod na process doon sa bakal. So, for example, gusto nila mura lang, conventional. So, isa